This conference will now be recorded.
Good morning, students. In today's class, we are going to discuss about what is the effect of slip on induction motor. See, already we discussed, right? Induction motor is never run at a synchronous speed. It is always run at less than synchronous speed. The reason is the presence of slip. That's why it is rotating less than synchronous speed. So that is the reason. Now we need to discuss what is the effect of slip on rotor parameters. Before going to the topic, you need to know that what are the parameters are influencing the rotor speed. So మనకు ఇప్పుడు EMF అనుకోండి, EMF ఇండ్యూస్ ఎలా అవుతుంది? What are the parameters affects the induced EMF? EMF ఇండ్యూస్ అంటే ఏమేం పారామీటర్స్ కావాలి మనకి? If you take a transformer, so how the EMF will be induced? What are the parameters are influencing? Right, current, then so current, flux. So these are the parameters are influence the induced EMF. Similarly, in induction motor, see already we discussed induction motor is compared with transformer. The only difference is in transformer the secondary is stationary. In induction motor the secondary is rotating. That is only difference in between transformer and induction motor. Now why induction motor is rotating less than synchronous speed? What is the reason? Is the main reason is presence of slip. If the slip is presented in that induction motor, what are the parameters affected by the slip, and why this rotor should be rotating less than synchronous speed? So let me discuss in this class. And here you have to know that what are the parameters we are using in this topic. The first one is NS. NS is denoted by synchronous speed. Next one is NR. NR is a rotor speed. Next one is S. S is slip. And so here, what is the formula for NS? NS is equals to 120 F by P. And what is the relation between these three? That is slip, synchronous speed and rotor speed. S is equals to NS minus NR divided by NS. And so this is the slip formula. If you want to represent this value in terms of percentage, you had to be multiply with 100. So S percentage is equals to NS minus NR divided by NS into 100. So these are the formulas which are related to the synchronous speed, rotor speed and slip speed. Now we can the S into NS, we can write NS minus NR. This equation we can call it as a slip speed. Slip speed అంటే మామూలుగా మన ఇండక్షన్ మోటార్ అనేది సింక్రనస్ స్పీడ్ లో రొటేట్ అవ్వాలి, కానీ రొటేట్ అవ్వదు. అంటే it is always less than the synchronous speed and it is generated by rotor speed. So now we need to find that what is the amount of speed was slipped. So that is given by slip speed. So NS minus the synchronous speed minus rotor speed. Then we can find that this much of amount speed will be reduced because of slip. Now we are going to discuss about effect of slip on rotor parameters. Now before that you need to know that what are the rotor parameters are including in the induction motor. So I will tell you that. The first one is FR. FR is a rotor frequency. Next one is E2R. rotor induced EMF. Next one is X2R, rotor reactance. Next one is I2R, rotor current. And next one is cos pi, pi R, that is power factor. Now these are the 5 rotor parameters are influenced by the slip, and these parameters we are representing at running condition. So when the motor is running condition, then we can represent rotor frequencies FR. E2R means, so already we seen that so rotor is compared to the transformer, it is secondary, right? That's why I am representing E2R, that is rotor induced EMF. X2R rotor reactance, I2R rotor current and power factor. These 5 parameters we can represent at running condition. Now we see that at starting condition. So starting condition, these 5 parameters we can represent F, E2, X2, I2 and cos pi. So these are the 5 parameters at starting condition. Now let me tell you that what is the difference between starting condition and running condition. If you observe the starting condition, starting lo manaku rotor speed 0 untundi and S is equals to 1. So this is the condition, starting condition. సో ఎందుకంటే మనం ఎప్పుడైతే సప్లై ఇస్తామో స్టేటర్ కి, అది ఫ్లక్స్ జనరేట్ చేస్తుంది స్టేటర్ లో. సో అప్పుడు ఏమవుతుందంటే ఆ ఫ్లక్స్ అనేది సింక్రనస్ స్పీడ్ లో రొటేట్ అవుతుంది. సో దిస్ ఇస్ ద స్టార్టింగ్ కండిషన్. అండ్ దిస్ కండిషన్ ద రోటర్ ఇస్ నెవర్ స్టార్ట్. రోటర్ అనేది స్టార్ట్ కాదు. సో రోటర్ స్టార్ట్ అవడానికి సమ్ టైం పడుతుంది, ఓకేనా. సో అందుకనే ఇనిషియల్, దట్ ఇస్ స్టార్టింగ్ కండిషన్, రోటర్ స్పీడ్ ఇస్ 0 అండ్ S is equals to 1, ఓకేనా. నెక్స్ట్ రన్నింగ్ కండిషన్ ఏమవుతుంటే ఎస్ అనేది 0 కి 1 కి మధ్యలో వేరీ అవుతుంది. అండ్ హియర్ ఎన్ఆర్ ఇస్ లెస్ దాన్ ఎన్ఎస్. నౌ హియర్ హౌ వి కెన్ రిప్రజెంట్ దిస్ ఈక్వేషన్ అంటే స్టార్టింగ్ ఫ్రీక్వెన్సీకి రన్నింగ్ ఫ్రీక్వెన్సీకి ఎలా ఉంటుందంటే, స్టార్టింగ్ ఫ్రీక్వెన్సీ అంటే స్టార్టింగ్ కండిషన్స్ లో ఎఫ్ అనేది 50 హెర్ట్జ్ ఉంటే, రన్నింగ్ కండిషన్ ఏమవుతుంటే ఎఫ్ఆర్ ఇస్ ఈక్వల్స్ టు ఎస్ఎఫ్ అంటే స్లిప్ అనేది ఇంట్రడ్యూస్ అవుతుంది రన్నింగ్ కండిషన్ లో. అలాగే E2R is equals to SE2. సో ప్రతి ఒక్క దానికి S తో మల్టిప్లై అవుతుంది అట్ రన్నింగ్ కండిషన్. స్టార్టింగ్ కండిషన్ ఏమవుతుంది, సప్లై ఫ్రీక్వెన్సీ is equals to FR because S equals to 1 అవుతుంది, ఓకేనా. సో దిస్ ఇస్ ద డెరివేషన్ we are going to be discussed in class. So this, please remember these 5 parameters in rotor, that is rotor frequency, rotor induced EMF, rotor reactance, rotor current and power factor. So these 5 parameters are very important, and these 5 parameters are gives that how much of speed has to be rotated by the induction motor. Right, see here, generally in practically, because in practically the speed attained by the rotor is less than the synchronous speed. So already we tell, so the induction motor is always runs at less than the synchronous speed. The difference between synchronous speed and rotor speed is called as slip speed. So that is S into Ns is equals to Ns minus Nr. So this is called as slip speed. అంటే ఎంత స్పీడ్ అనేది రెడ్యూస్ అయింది సింక్రనస్ స్పీడ్ తో కంపేర్ చేస్తే, సో దట్ ఈస్ గివెన్ బై దట్ స్లిప్ స్పీడ్. సో ఇక్కడ మీరు 3 పారామీటర్స్ గుర్తుపెట్టుకోవాలి, స్లిప్ స్పీడ్ అండ్ సింక్రనస్ స్పీడ్. సో దీస్ 3 notations are very important. Now the slip speed of induction motor is defined as difference between synchronous speed and rotor speed divided by Ns. So if you represent the slip equation in the form of S is equals to Ns minus Nr divided by Ns, it is called as absolute slip. So sometimes they will ask in problems. So find out the absolute slip, find out the slip speed. So we have to note on that. Next, if you want to represent in terms of slip is percentage. So you have to multiply with yes. So generally the slip should be vary in induction motor is 1% to 5%. That is 0.01 to 0.005. This is the normal slip value lies in real-time induction motor. So మన రియల్ గా యూజ్ చేసే ప్రతి ఇండక్షన్ మోటార్ లో స్లిప్ అనేది ఈ రేంజెస్ మధ్యలో ఉంటుంది 0.01 to 0.05. Already we seen right, the slip is always lies in between 0 to 1. So that's why in India, so in our situation, in our country, we are getting the slip value is 0.01 to 0.05. Now we will see that how much of variation is happening here. Right. In terms of slip, the actual speed of motor, that is rotor speed, can be expressed as NR is equals to NS into 1 minus S. Okay, ఇక్కడ మీరు గుర్తు పెట్టుకోవాల్సిన ఫార్ములాస్ ఏంటంటే స్లిప్ ఒకటి, NS ఒకటి, NR ఒకటి. So three formulas very important. If you want to, if they will give that rotor speed and synchronous speed, and you have to find the slip. So NS minus NR divided by NS. If you know this formula, then you can obtain this formula. And the NS formula is 120 F by P. Now, from this equation, we can obtain this. Why? Because so just to cross multiply this, NS into S equals to NS minus NR. If you want to find the rotor speed, just bring this side and this one bring this side. So NR is equals to NS minus S into NS, and take the common as NS 1 minus S. Okay, now suppose what is the S value at starting condition? What is the S value at starting condition? 1, right? Suppose if you substitute 1 here, what will get? NR is equals to 0. So already I told you that at starting condition rotor speed is 0 and slip is 1. Now we verified. See here, at starting it is rest, the motor is rest condition and its speed is 0. So because of S is equals to 1. Now this is the maximum value of slip. S is possible for induction motor because the S is varies between 0 to 1. So here this is the minimum value and it is the maximum value. So this is the maximum value of slip and possible for induction motor occurs at start, while S is equals to 0 gives the synchronous speed is equal to rotor speed, but in induction motor is never possible. So it never S is equals to 0, which is not possible for induction motor. So slip of induction motor cannot be 0 at any conditions, because the slip is maximum, the minimum value of slip should be 0.01. It never be 0. If it is 0 means then we can call it as a synchronous motor, but in induction motor it won't be possible. In practically the motor operates in the slip range of 0.01 to 0.05. So we can represent in terms of percentages 1% to 5%. Now are clear about these three parameters, slip, NS and NR. So keep remember these formulas. And slip ranges in induction motor is 1% to 5%. It is also most important ranges. And next thing is at in objective question I may ask what is the S value at starting condition? S is equals to 1. What is the rotor speed at starting condition? NR equals to 0. So these are the parameters and these are the conditions you have to be remembered. Then only you can understand the concept. Now let me see that effect of rotor parameters on, so effect of slip on rotor parameter. Okay, now see here, we will discuss one by one here. In case of transformer, the frequency of induced EMF in the secondary is same as primary. So if you take that transformer, so we have that EMF equation, right? E1 is equals to 4.44 F N1 pi M. for E2 for induced EMF on secondary is equals to 4.44 F N2 and pi F. Now, if you observe that this equation, the number of turns are varying, but the frequency is constant. That's why the transformer we can call it as a constant frequency device. But in the case of induction motor, it never possible. It is always variation from the stator frequency and rotor frequency because of presence of slip. See here, the rotor frequency is equals to S into F. Rotor frequency is a S times of supply frequency. At starting condition, the rotor frequency is equal to supply frequency. But when the rotor is gain its speed, there is a presence of slip. Suppose if the rotor the supply frequency is 50 Hz, right? Now your slip is 0.01. Then what you will get here? What is the rotor frequency? It may be so 0.01 into 50. So it should be reduced, right? So because of slip, the rotor parameters are reduced when compared to the stator. Now these are the parameters are influenced by the slip in the rotor. One is rotor frequency, rotor induced EMF, rotor reactance, rotor current, and rotor power factor. Okay, so these are the 5 parameters are influenced by the slip. That's why the induction motor should never run at synchronous speed. Now we'll see that what is the relation of rotor frequency with respect to the starting condition, running condition among these 5. So let me discuss one by one. See, first one is effect on rotor frequency. So now let me see that how the slip will be affects the rotor frequency. Now the relation between the frequency and the synchronous speed, we have only one equation, that is ns is equals to 120 f by p. Now let me so this is the here f is equals to frequency of supply in hertz. At starting condition, the rotor speed is equals to 0 and slip is equals to 1, and the stationary rotor has maximum relative motion with respect to the rotor magnetic field, and hence maximum EMF is induced. Okay, now here this is the starting condition. When it is comes to the rotor condition, that is running condition, what you will get? 120 into FR divided by P. Okay, so this is the starting condition and it is a running condition, and in this case NS minus NR. Now represent this is equation 2. So this is the starting condition we can obtain, and this is the running condition. Let me tell you that at starting condition NR equals to 0. So then you will get that starting condition equation. So NS is equals to 120 F by P. It is a speed of rotating magnetic field. ఈ కండిషన్ ఏమవుతుంటే రోటర్ అనేది రొటేట్ కాదు. సో ఓన్లీ మనకు రొటేటింగ్ మ్యాగ్నెటిక్ ఫీల్డ్ ఒకటి రొటేట్ అవుతూ ఉంటది. ఎప్పుడైతే రోటర్ అనేది రొటేట్ అవుతుందో దెన్ వి కెన్ రిప్రజెంట్ NS minus NR is equals to 120 FR by P. Okay na? So this is the speed when the rotor is gain its speed. Okay na? Now let me divide equation 2 by equation 1. What you will get? NS minus NR divided by NS is equals to 120 FR divided by 120 F. Now what you will get from this relation? What is the formula of this? LH side, that is slip. S is equals to 120 get cancelled. FR is equals to F. So finally you will get FR is equals to S into F. So here this one is rotor frequency and it is slip frequency. Now from this equation we can make the two cases. One is starting condition, running condition. At starting condition FR is equals to F because S is equals to 1. At running condition FR is equals to SF because S is varies between 0 to 1. So you have to make these two conditions for every cases, starting condition and running condition. So this is the equation we can obtain when the slip is effects on the rotor. See here, from this you can apply. Now this is the when we can write for the rotor in running condition is ns minus nr is equals to 120 fr by p. If you divide that equation 2 by 1, then you will get ns minus nr divided by ns, 120 fr by p divided by 120 f by p. So here 120 get cancelled, pp get cancelled. So s is equals to fr by s. Finally the rotor frequency is equals to sf. Remember this equation. Okay, so make problem అడుగుతాడు. Find the frequency at starting condition, running condition. So starting conditions లో తీసుకుంటే fr is equals to f అవుతుంది, and running condition తీసుకుంటే fr is equals to sf అవుతుంది. ఓకేనా, ఈ రెండు ఫార్ములాస్ బాగా గుర్తుపెట్టుకోండి. స్టార్టింగ్ కండిషన్, రన్నింగ్ కండిషన్. రన్నింగ్ కండిషన్ లో స్లిప్ అనేది ప్రెజెంట్ అవుతుంది, స్టార్టింగ్ కండిషన్ లో స్లిప్ అనేది 1 అవుతుంది. ఓకేనా. Now let me see the second parameter influenced by the slip. Right. Effect on the magnitude of induced EMF in the induction motor. Now when the rotor is standstill condition, S is equals to 1. The relative speed is maximum and maximum EMF gets induced in the rotor. Now we can represent that E2 is the rotor induced EMF at starting condition. Okay, so E2 and E2R is rotor induced EMF at running condition. It is starting condition, running condition. Okay, now its rotor gain speed, the relative speed between the rotor and rotor magnetic field. Ante rotor speed ki induced, that is synchronous speed ki etuvanti difference vastundi. Okay, so here from starting the induced EMF in the rotor is directly proportional to the synchronous speed, because this is the starting condition. Now when it is running condition, the E2 is directly proportional to that ns minus nr. So we can represent it is E2R. Now say if you divide that equation 2 by equation, you will get S is equals to E2R divided by E2. And finally E2R, that is rotor induced EMF is at running condition is equals to S into rotor induced EMF at starting condition. E2 is rotor induced EMF at starting condition, E2R is rotor induced EMF at running condition, and the relation between these two is E2R is equals to S into E2. So from this relation you can get the supply, the rotor induced EMF is always less than that induced EMF on the rotor. So this is the running condition. Running condition eppudu starting condition kanna takku untundi because of slip. Okay, so this is the second formula. E2R is equals to S into E2. Next, effect on the rotor reactance. Now we already know that in transformer, so transformer kaavachu, induction motor kaavachu, rendu combine kusa, it combination of R plus JX. So if you are talking about rotor, means I am going to represent R2 and X2. Okay, now this is the so we can represent R2 and X2 at standstill condition, at starting condition. Next, R2R, X2R. These are the running condition. Now here I can represent reactance in terms of frequency 2 pi FR and L2. So మాకు తెలుసు కదా రియాక్టెన్స్ ని 2 pi FL. సో మరి మీరు నెట్వర్క్ అనాలిసిస్ చదివారు. ఓకేనా. Now this is the reactance formula for ohm per phase. Now from this relation let me discuss how the relation. So we can simply say that X2R is equals to X into X2. This is the relation with respect to the slip on reactance. Running reactance is equals to slip into starting reactance. So ఇది ఎలా వచ్చింది ఇప్పుడు చూస్తాం. Right. So from this equation FR is, so మనకు already FR is equals to SF అని తెలుసు. So ఇక్కడ మీకు చూస్తే X2 is equals to 2 pi F L2. This is the starting reactance value, starting condition. So starting condition ఏమవుతుంది, S is equals to 1 అవుతుంది, F is equals to FR అవుతుంది. But in running condition, X2R is equals to 2 pi FR L2. సో ఇప్పుడు మనకు రన్నింగ్ కండిషన్ లో F1 ఏం రాసుకోవచ్చు, SF రాసుకోవచ్చు కదా, 2 pi SF and L2. సో సేమ్ హియర్ 2 pi SF. సో ఇప్పుడు ఏం చేస్తాము, X2R ని ఇక్కడ అడిషనల్ గా S వచ్చింది, S into X2. So this is the reactance value of starting condition. Now if you want to represent the impedance value, E2 is equals to square root of R2 square plus X2 square. This is the starting condition. If you want to find the running condition, Z2R is equals to R2 square plus S into X2 square. సో ఇక్కడ ఎస్ ఒక్కటి ఇంట్రడ్యూస్ అవుతుంది. ఇది స్టార్టింగ్ కండిషన్ అయితే ఇది రన్నింగ్ కండిషన్. మనకి ఇండక్షన్ మోటార్లో రెండు కేసెస్ గురించి మాట్లాడాలి, ఒకటి స్టార్టింగ్ కండిషన్ గురించి, రన్నింగ్ కండిషన్ గురించి. ఓకేనా, స్టార్టింగ్ కండిషన్స్ లో ఎస్ అనేది ఉండదు, రన్నింగ్ కండిషన్ ఎస్ అనేది ఇంట్రడ్యూస్ అవుతుంది. సో దిస్ ఇస్ ద ఈక్వేషన్ విచ్ ఈస్ రిప్రజెంటెడ్ టు దట్ రోటర్ రియాక్టెన్స్. నెక్స్ట్, రోటర్ పవర్ ఫ్యాక్టర్. Now if you know this right angle triangle with relation between impedance and reactance resistance, so this is the reactance value. Now from this, if you want to find the power factor, so power factor is cos pi only, right? So cos pi is equals to opposite side divided by adjacent side divided by hypotenuse. What is adjacent side? R2 divided by Z2. So what you will get, so this is the cos pi value. So cos pi is equals to R2 divided by square root of R2 square plus X2 square. This is the cos pi value at starting condition. Now if you want to find for running condition, cos pi is equals to R2 divided by square root of R2 square plus X2 square. So ఇక్కడ చూడండి, ఇక్కడ S లేదు, so that's why it is transitional condition. Here S is introduced at running condition. So see here, as rotor winding is inductive, the rotor power factor is always lagging in nature. Okay na, మనం యూజ్ చేసే వైండింగ్ ఎప్పుడు లాగింగ్ లో ఉంటుంది, బికాస్ ఇట్ ఈస్ ఇండక్టివ్ ఇన్ నేచర్. ఓకేనా, అందుకని మనం ఎక్సెల్ అని రిప్రజెంట్ చేస్తే ఇట్ ఈస్ ఇండక్టివ్ ఇన్ నేచర్. ఓకేనా, so this is the power factor, rotor power factor affected by the slip. Next, rotor current. What is the formula for current? I is equals to V by R, right? But here V is a induced EMF, that is I, E, and R we can represent Z. So if you want to find the secondary, that is rotor, I2 equals to E2 divided by square root of R2 square plus X2 square. So this is the equation at starting condition. Okay, so I2 is equals to E2 divided by square root of R2 square plus X2 square. If you want to represent this equation for running condition, we can represent I2R is equals to S into E2 divided by square root of R2 square plus SX2 whole square. So these are the formulas, these are the factors affected by the slip on rotor. That's why the induction motor is rotating at that less than synchronous speed. Okay students, this is about today's class. I'm having that exam duty, that's why I'm going to end this class. Okay, so మీరు ఏం చేస్తారంటే ఒక చిన్న పేపర్ తీసుకొని రన్నింగ్ కండిషన్ కి స్టార్టింగ్ కండిషన్ కి ఈక్వేషన్ రాసుకుంటూ వచ్చేయండి. Then you can get that clarification, అంటే స్టార్టింగ్ కండిషన్ లో ఎలా ఉంటుంది ఈక్వేషన్, రన్నింగ్ కండిషన్ లో ఎలా ఉంటుంది. సో నాకు ఈ రోజు ఈవినింగ్ లోపల ఈ ఫార్ములాస్ అని ఒక పేపర్ లో రాసి నాకు వాట్సాప్ చేయండి. ఓకేనా, సో దిస్ ఈస్ యువర్ అసైన్మెంట్. ఓకే స్టూడెంట్స్, ఐఎమ్ గోయింగ్ టు ఎండ్ దిస్ క్లాస్ నౌ. Wait for 2 minutes, I'm going to take the attendance, then you can leave the class. 423 is there. 4, 423. So I'm going to tell you the option is 406. 406 is there? No, right? 406 and 420. 423. So these are the three persons are option, right? So okay, students, I'm going to end this class, and you have to submit that these formulas before evening.